So let's discuss about VLAN. VLAN is the short form for virtual LAN or virtual local area network. Now what it does, VLAN is usually used to logically break up broadcast domain in layer 2 network or switching network. Now let's see what that means. Okay. Now this is a Cisco switch. When you buy a switch, when we usually buy a switch, basically all of these ports are in VLAN 1 by default. Okay, all of these 48 ports in VLAN 1. Now basically a switch is supposed to indicate one subnet. Okay, so one VLAN ID indicates one broadcast domain, and one switch also indicates one broadcast domain. So here in VLAN, it's a technology, alright. So what it does is we can logically break this broadcast domain into, say there are 48 ports in this switch. We can logically break this up into 48 broadcast domains. Okay, so let's move forward and see. VLANs generally fall into two categories: standard and extended. Now let's see what is standard VLAN first, and then we will see what is extended VLAN. Standard VLAN. Standard VLAN's range is from 1 to 1005. It's decimal number 1 to 1005. So extended VLAN, the extended VLAN range is from 1006 to 1094. So VLANs range from 1 to 4094. So till now VLANs range from 1 to 4094. As we move forward, we will see many such many such things that will take into account more VLANs. So as I said, as we have introduced VLAN 1 as the default VLAN, so it is the default Ethernet access VLAN, and it cannot be deleted. It is present in the switch by default, and obviously it should not be used for actual port assignments because it's by default present. So further indication, we cannot use it for further port assignments. And I'll be discussing about BTP in next sessions, in the upcoming sessions. So we will not see about this now. Just know that standard VLANs can be configured on server mode, BTP server mode, and extended VLANs in BTP transparent mode. We'll see what is BTP transparent mode and server mode in the later sessions. Now operation, how the VLAN operates, how we can tag VLAN, how we can communicate between different VLANs. This we will see in the end. For now, we will dive into configuration. So let's start configuring. Yes. So in the last session we studied about trunking, and trunking means when one switch is connected to the other, this port will be trunked. This FA01 0/1 and this FA0/1 should be a trunk port. Now let's go and configure this first. In my config mode, interface pass Ethernet 0/1, switch port mode trunk. Now my trunk configuration is complete. What I need to do is configure the access ports. Now access port works only on the end device. Okay, so the interface that connects the end device is FS0/2. So let's go and configure it. Switch port, mode, access. Done. Now here too. So it will be FS02. Switch port, mode, access. Now my trunk and access ports have been configured. What I need to do is creation of VLAN. So let's see what are the commands. To create a single VLAN, I mean, like you saw in the diagram. Where is it? Okay, yes. To create a single VLAN like VLAN 10 or VLAN 20, we need to use this command VLAN in any number between 1 to 1005, just because by default every switch is in BTP server mode. So as I said that here, as I said that standard VLAN can be configured on BTP server mode and extended VLANs only on transfer mode. So here, as every switch by default is on BTP server mode, so we need to I cannot say that we cannot create an extended VLAN, because we can also transfer the we can also change the mode of a BTP. So more about BTP in our upcoming sessions. For now, just know that standard VLAN ranges from 1 to 1005, and it's for BTP server mode, and from 1006 to 4094 it's extended VLAN, and it's for BTP transfer mode. So to create VLAN, this is the command, and we also have to give a name to it. It's for you know, if we are naming it like for IT, department of IT, that means the whole department of IT is on VLAN 10. So for naming purposes we need to name it. Well, let's go ahead. Okay. VLAN 10, name IT. Now I'm going to name this PC as PC1 IT department. This PC also PC2 IT department. So by naming this PC as 1 and 2, both of the IP department, so I can think that both will be on the same subnet. So that means that I have to configure same VLAN on both the PCs, on both the ports. So let's do it. This is on FS0/2. We have created VLAN 10. So notice the command over here, switch port access VLAN 10. Switch port access, because we are configuring it in an access port, so we have to give this and then the VLAN. Okay. Now see, the command for verification is show VLAN brief, and this this will show us what is the VLAN created, what are the VLANs created, and what is the name for it, if at all we have given a name, and the ports associated with it. Okay, so IT and 10 is associated with the port FS0/2. Now let's do the same for this port, this switch. Switch port access VLAN 10. Okay. Yes. Now we have to name it. So see, first we have to create the VLAN and then we have to access it. Access VLAN 10, and there you go, it has been created. Now let's verify it. See, so before making it an access port and then creating it, so the best idea is to first create the VLAN, then name it, and then specify or use it in the particular access port. So now we should ping it and let's see what happens. Stop IP, let's say 192.168.10.5 is my IP address, and the default gateway is 10.1. Okay, and here also same, 10.1 should be the default gateway. Let's say 6, and actually we do not need the default gateway right now because we are not dealing with anything from layer 3, it's all layer 2. So let's hope that we can ping it. 10.6, yes. 192.168.10.6. Yes, we are getting the ping reply. So let me configure this as VLAN 20. I mean, FS0/2 should be on VLAN 20. Okay. No VLAN. So let me delete it. Let me delete it. No VLAN 10. Okay. Now let's verify it. Show VLAN brief. See, VLAN 10 that was created previously is now gone because I used the command no VLAN 10. In Cisco, anything, I mean any command you give, and before that if you add no as a prefix, it will act as, it will act as a disable command, you know. So for deleting a VLAN you can use no and then VLAN and then the number. So as you see here, delete a VLAN, see no VLAN 50. 50 is the number that you can give, or any number. So this is how you can delete a VLAN. Now let's add a VLAN that is not 10. Okay, so by that we will see that if we can communicate with another VLAN in the same subnet. Okay, let's see. Name, say accounts, switch. Media accounts is there. Okay. Switch port access VLAN 20 and exit. Let's yes 20 accounts and then FA0/2. Okay. Now I should ping and then let's see if it can communicate or not. We are not getting the ping reply. This is because VLAN 10 can only communicate with VLAN 10. If it wants to communicate with another VLAN, there has to be some extra information. So right now we are not going to discuss about that. We are just going to learn that if a PC is on VLAN 10 and it wants to communicate with another PC on VLAN 20, it cannot communicate because both of them are on different subnets. Okay. Then we can also create a range of VLAN with the same command, but only difference is that suppose we are going to create a range of VLAN, say 50 to 60. So VLAN in space 50 to 60. Then we have then if you want to delete it, then we have to add a prefix of no. Okay. So this is about the configuration, and let's see the operation VLAN is. Now this is similar to what we saw in the practical. Now here this PC is on VLAN 10, this PC is on VLAN 10, and this PC is on VLAN 10. Now as we have learned that these are the access ports only carry the raw data, okay, and trunk ports carry the data and the VLAN ID tag. I mean, if VLAN 10 is going to communicate with VLAN 10, this port will generate the computer will generate the data, and this port will carry the data, and here in the switch it will encapsulate with the VLAN tag. I mean, whatever data is generated here will come here in the switch, and with the addition of the VLAN tag, I mean, the packet should look like data plus the VLAN tag, VLAN 10. This should be the packet that will come out of this port. See, data, whatever raw data is generated here, access port will carry it uh, from FA to FA01 interface, and then through FA0/10 interface the switch will pass out the packet as data plus the VLAN ID tag. This is because we saw that in trunk we need to add a command called switch port trunk encapsulation. This encapsulates the data with the VLAN ID tag and then sends it through the trunk port. And we also saw that VLAN, the switch ports are part of only one voice VLAN and only one data VLAN, and the trunk ports are part of all the VLANs. So this is why when there is multiple VLANs, VLAN 10, VLAN 20, VLAN 30, then we need to have a trunk port, because the trunk port will carry all the VLAN tag and all the VLAN packets along with the original raw data packets to the other end of the switch, and they are going to be distributed likewise. So when this packet when this data plus VLAN ID tag reaches this switch, it forwards it by looking at the MAC address, and then the supposed data is reached to the destination. So VLAN 10, the access ports do not contain any VLAN ID tag data. It only contains the raw data. So over here you will only get data, and here you will get data plus the VLAN ID tag. So this is how it operates, and we'll see about VLAN extensively in the next session, and also some lab. This was just an introduction, and the next sessions will be big, because I'll be explaining more about the operation and how the data passes through the ports, and more about the labs. So that's going to be it for today. Thank you.